let's see how to calibrate the compass and to show you how bearing works with GPS values. So I've got the GPS navigation program in here. I'll just reset it. Okay, to start off with, it says move to location and press button 2. So this is the goal location. What I've done is I've marked the goal location with a tag here with a marker. And you can see that straight away it's got the GPS location. So that is going to be the goal location of where we want the robot to go. So I either move there, I'm here anyway, and then press button 2. So I'll press button 2 and then wait for my next instructions. So those are the GPS coordinates of where it is, and it will always try and get back there. So that's the goal. Now it says top distance and then GPS bearing and then actual robot bearing. So this is going to be the distance to the goal, which is 0, obviously. This is the bearing to the goal, and this is the bearing of the robot. As I rotate the robot around, you can see the bearing changing. So if I move this to about 0 degrees, then you can see that there is north. So it's facing northwards, 0 degrees bearing. Okay, what I'm going to do now is take the robot and move away from the goal. Now as I move the robot away from the goal, you can see the distance on the top number is changing. So I'm 10 meters away now. I'll keep walking. Ideally, you want to be quite far away, about 20 meters or so. So I'm 20 meters away according to the GPS. Okay. Now, what it will do is read its GPS location and calculate the bearing needed to get to that location. So that's the bearing needed. So it's 136 degrees, okay, in that direction. So that is nothing to do with the orientation of the robot. It's just the position of the robot. So GPS gives me position. What this number does is tell me the bearing of the robot itself. So if the robot was to get to that location, it would need to drive in that direction. So it's facing the cone. Okay, so one way of testing your bearing or calibrating it is to say, well, if I'm facing the cone directly, then the two bearings should be the same. So that's the bearing to the cone, and this is the bearing according to the robot. Now you can see that there's a bit of a discrepancy there. So I'm making sure that my robot is facing the cone exactly, and the discrepancy is just due to magnetic aberration. So what I can do is I can just change my bearing. Every time I click either button 1 or button 3, I can make it either go down or up. So it's working on its local GPS bearing, but I can just make them, ideally they should be exactly the same. So 137, 137. Okay, might make it 138. So just increase, and then it saves that into its memory. Now as I move the robot away from its bearing, and let's move it to a different location and see how the bearing changes. So I'm keeping more or less the same distance, but because I'm moving laterally, you can see that the bearing, the bottom left-hand bearing, is changing because it's due to the position. So now I've moved over here. So the absolute bearing to the cone from the robot is 168 degrees. So if the robot was to face the cone, I would want those two values to be more or less the same. So there's always going to be a discrepancy because GPS isn't 100% accurate. Compass is using magnetism, so it's not going to be 100% accurate. So the reason why that's pretty close though, that's quite good. And the reason why I've kept these buttons here is because you can really test it at different points and just see how accurate your bearing is. So as I move this to a different location, so as I'm moving the bearing location to the cone that you can see there is moving. Okay, so let's have a look at the bearing from the robot to the cone. So the bearing from the robot to the cone is 228 degrees. I'm a bit closer now, and 9 meters away. And if the robot was facing the cone, so cone is over there, let's get the robot to face the cone. Like that. So you would expect the bearing of the robot and the bearing of the cone to be more or less the same. There's a discrepancy there, probably about 20 degrees. So I can calibrate it slightly. Maybe I'll just want to increase this magnetic offset. It's really just about finding a happy medium between the two values. You might notice this is actually come down because it's calculated from GPS. So I can move around and test my absolute bearing from the robot to the cone and just see how it goes. So now I've moved, my robot is facing the cone.